Hello again and welcome to Cambridge Advanced Level Mathematics, the channel that prepares students for their Cambridge Advanced Level Mathematics examinations. Today's problem is problem number 10, taken from paper 1 of 2020, and the question reads as follows. A curve is such that d2y dx squared is equal to 6x squared minus 4 divided by x cubed. Number 2, the point minus 1, 9 over 2, is a stationary point. So the first question says, determine the nature of the stationary point. Second question says, find the equation of the curve. Third question, show that the curve has no other stationary point except this one. And the third or fourth question rather is a point A is moving along the curve such that the y coordinate of A is increasing at the rate of 5 units per second. Find the rate of increase of the x coordinate at the point x is equal to A. Quite a lot of things involved here, but let's see what those things are. Okay, so our first question says, determine the nature of the stationary point. Very quickly, of course, first of all, we note that we have been given the 2y dx squared is equal to 6x squared minus 4 over x cubed. So if we are going to investigate the nature of this point, we have to use the second derivative method of investigating our stationary point. How does that work? Well, if you have a minimum point here, we know that at the minimum point, of course, our dy dx is equal to 0, and the curve is parallel to the x-axis. But what happens is we approach the point from in a positive direction of the x-axis. Here we have a negative slope before the minimum point. Then at the minimum point, our slope is equal to 0. After the minimum point, our slope is positive. So what is slope? Slope is dy dx. So this means that as we approach this in a positive x-axis direction, our slope, our dy dx, is increasing because it starts negative, goes through 0, and becomes positive. So if dy dx is increasing, that means our d2y dx squared is greater than 0. It's positive. That's for a minimum point. Over here, where we have a maximum point, the opposite is happening. Of course, here again, our dy dx is still 0, and the curve parallel to the x-axis. But as we approach it from this in the positive x direction, we start off with a negative slope. It goes to 0, then it becomes, so yes, positive here, goes through 0, and it becomes negative. So slope again is dy dx. So dy dx is decreasing, positive, 0, negative. So if dy dx is decreasing, that means our d2y dx squared is less than 0, because dy dx is decreasing in that direction, being the opposite of that. Now, given this analysis, how then do we investigate the nature of this point? Well, we can see that at this point, our x is equal to minus 1. Here is our expression for dy dx. So we simply need to plug in minus 1 for x and see the sign of the value of dy dx. If it's positive, then we are here. If it's negative, then we are here. Okay, let's see what happens there. So our d2y dx squared is equal to 6x squared minus 4 divided by x cubed. put x is equal to minus 1, you get 6 brackets minus 1 to the power 2 minus 4 brackets minus 1 raised to the power 3. Well, minus 1 squared is just 1, so that becomes a 6 there. And 4 divided by minus 1, and this minus here, it changes into a plus. So we end up with 6 plus 4, which of course is greater than 0. So we are here. Our point is a minimum point. Okay? Let's do some more. Okay? It says here in B, find the equation of the curve. We now want to find y because we are only given the second derivative. How do we go to y itself? Well, we know that our d2y, first of all, our d2y dx squared is actually equal to dx of what? Of dy dx. In other words, the second derivative of y with respect to x is obtained when we differentiate the first derivative with respect to x. So if we are given the second derivative, how do we get back our dy dx? We simply integrate that, because integration is the inverse of differentiation, or differentiation is the inverse of integration. So here we are given this. We want to go back to that, we must integrate this. So in other words, dy dx is equal to the integral of d2y dx squared, all with respect to x. So we must integrate d2y dx squared with respect to x, which of course is what we were given there, 6x squared minus 4 divided by x to the power 3 with respect to x. Let me write it in a way that makes life simple for me. 6x squared minus 4x to the power minus 3, or with respect to x. I find it simpler to handle when it's like that. Integrating that, we get our, here we raise our power to 3, then we divide it there, so it becomes 2x to the power 3. Here we raise it to minus 2, and then we divide it here. So minus 4 divided by minus 2 is plus 2x to the power minus 2. Okay, let's just check our differentiation there. This was raised to the power, it becomes minus 2. This was negative, it becomes plus there. Okay, but of course we need a constant of integration, an arbitrary constant. So this is our dy dx. Okay, but what do we know? We know that this curve has a minimum that we have already found that, and at a minimum point your dy dx, we noted it's equal to 0. So if dy dx is equal to 0 at this point, it means that if we put minus 1, the value of x there, in this expression, we should get 0 over here. So we can now say 2 brackets minus 1 cubed plus 2 brackets minus 1 to the power minus 2 plus k, all this should equal to 0, because at that point your dy dx is equal to 0. Let's evaluate this. This is minus 2, because minus 1 cubed is minus 1. So this becomes a minus 2. Here it is a plus 2, then plus our k there is equal to 0. So this and that is nothing. So that leaves k is equal to 0. So the expression for dy dx, let's put it up here somewhere. Our expression for dy dx will then be dy dx is equal to this one here, 2x to the power 3 plus 2x to the power minus 3, or minus 2, sorry, to the power minus 2 there. So put it inside our nice little box there. So that's our expression for our dy dx. But we haven't arrived at where we want to go, because what we want is y. So how do we get our y? Using exactly the same reasoning as before, we know very well now that our y will be equal to the integral of dy dx with respect to x. Because remember, to get dy dx, we must differentiate this. So to get our y, we must integrate that. So we now integrate that expression there, which is equal to 2x to the power 3 plus 2x to the power minus 2 with respect to x. Integrating again, the power is raised to 4 there, we divide it there, it becomes 1 over 2x to the power 4. Here it becomes minus 1, we divide 2 by minus 1, we get minus 2x to the power minus 1 plus a constant. So this is equal to our y there. Okay, how do we get our k? We know that this curve passes through this point here, the point minus 1, 9 over 2. In other words, at this point, our y is equal to 9 over 2, and our x is equal to minus 1. So we can substitute those values into this equation and get 9 over 2 is equal to half, brackets minus 1, x is minus 1 at that point, to the power 4, minus 2 minus 1 to the power minus 1 plus our k. Right, let's simplify. This is 9 over 2. 1 minus 1 to the power 4 is just equal to 1, so that remains a half. Here we have a minus 1 to the power 1, which is minus 1, plus this minus here. Then we have a 2 plus our k. Let's just multiply everybody by 2 to get rid of this denominator. Then we end up with, here we have, on this side we have 9. Here it's just 1 there. Here we have a 4, because 2, this was like 2 over 1. Here again we have a 2k. Okay, 1 plus 4 is 5. Taking our 5 to this side, we remain with 4 is equal to 2k, meaning our k is equal to 2. So our expression for y will be this one here. This is our expression here, where k now is equal to 2. So y here, you can put it here, is equal to 1 over 2 x to the power 4 minus 2 x to the power minus 1 plus what? Plus 2. We said k is equal to 2 there. Okay. Right. K is equal to 2. All right. Right. So the next question says, show that the curve has no other stationary point. Okay. Now we know that at a stationary point, dy dx is equal to 0. So the values of x for which this expression is equal to 0 will give us the points where the curve has a stationary point. So first of all, we have to equate this to 0, find what values of x we get there. If we get 2 values for x, then we know that there are 2 stationary points. If we get 3, then there are 3 stationary points. If we get 1, then we have got 1 stationary point. So let's find out what we get if we equate that to 0. So first of all, we know that at a stationary point, in an examination, this is what you would have to write, because you don't just jump to things. You must first of all say at a stationary point. dy dx is equal to 0. You are trying to show the examiner that this is where I am working from. We don't just jump and say this is equal to 0. The examiner will say, where are you getting this from? So, okay, once we have stated that, we can now proceed to say this implies that 2x to the power 3 plus 2x to the power minus 2 is equal to 0. Let's write it as 2x cubed plus 2 over x squared is equal to 0. Multiply everything by x squared, or let's say making x the common denominator, x squared the common denominator, you have 2x to the power 5. I'm multiplying here by x squared plus 2 here, all divided by x squared is equal to 0. Okay, you see there, I just made x squared the common denominator. I can bring out the x squared and write this implies 2 goes here, 2 goes there. I can write 2 over x squared brackets here. It goes your x cubed times, oh, x to the power 5. It's always x to the power 5. Here it goes 1 time. Okay, you see I factored out the 2 and this one here, so it goes that times and once there, and this is equal to 0. Now there are only 2 possibilities: either this is equal to 0 or that is equal to 0, but we cannot take this as being equal to 0 because it's undefined. So the only possibility is that x to the power 5 plus 1 is equal to 0, which implies that x is equal to minus 1. So the only possibility is that x is equal to 1, which we have there. So there is only one stationary point. We have proved that. If we had gotten 2 values, we would have proved that no, there are 2 stationary points. But there's only one there. Okay, our next question, a little bit more involved there. Question, if we done C, show that the curve has no others. Yes, we did. So now we are at D. Now D says a point A is moving along the curve such that the y-coordinate of A is increasing at the rate of 5 units per second. Now, the moment you hear the expression rate per second, second, of course, is time. So you are talking about the rate of change of y with respect to t. So in other words, straight away we can write this point is moving in such a way that its dy dt is equal to 5 units per second. It's with respect to t because we are talking about time there. Now the question says find the rate of increase of the x coordinate at a point where x is equal to 1. Now we don't know what dx dt is, the rate at which x is increasing with respect to t. But what do we know from parametric differentiation? Parametric differentiation tells us that dy dx is equal to dy dt divided by dx over dt. Okay, so what do we know here? Let's see what we are given. Do we have dy dx? Yes, we have an expression for dy dx, and when we put 1 there, we can actually get a number for dy dx. Well, so we do have this. Do we have dy dt? Yes, it's given. It's this value here. Do we have dx dt? No, that's what the examiner is looking for. So, okay, let's put in what we have. So here, first of all, let's find dy dx when x is equal to 1. We know that dy dx is equal to 2x cubed plus 2x to the power minus 2. Now, when x is 1, this is 1 cubed, which is 2, plus another 2 there, which is equal to 4. So when x is equal to 1, dy dx is equal to 4. So we can write 4 here. So this means that 4 is equal to, this one is 5. This one we don't know, which is dx over dt. Okay, so we can cross multiply. 4 dx dt is equal to 5. So what is dx dt? That gives us dx dt is equal to, remember we took dx dt over to this side, it becomes 4 dx dt. When you divide everybody by 4, it becomes then 5 over 4. 5 over 4. This is the rate at which x is increasing. The x coordinate is increasing with respect to time. That is our solution. Till next video, thank you very much and bye-bye.